Hello and welcome to another video of HVAC Calcs. We're going to take a quick look at airflow and AC heat pump calculations. Once again, in the description below will tell you how to get this file. We have some just basic calculations that people use all the time, and I like to have them all in one place. So let's calculate our delta T. Temperature drop rise through a heat exchanger. That's this calculator right here. Calculate airflow and you know the delta T right here. Clock and a gas meter. The way this one works is very simply drive dial, put the size of that in, how many seconds for one revolution of the drive dial, enter seconds or use stopwatch. So what you do is, if you want, you can just hit the start button and that'll put your start time on there, and you let it go, let it go, let it go. I will edit this in about 10 seconds. And then you hit the stop button. And it says it took 14 seconds to go one revolution. There's your cubic feet per hour. Now, if you have a 2.0 meter, 2.0 PSIG, put your elevation in. This will tell you your PSIA, your atmospheric pressure, cubic feet per hour at the burner tip, and your flow rate. You can use this for gas. Here's the one for gas, and here's the one for oil. So you need to know your nozzle firing rate and your pump pressure, the efficiency of your appliance. As you can see, 1 gallon, 100 psi is 1 gallon per hour. If you bump the pump pressure up to 150, you're actually burning 1.22 gallons per hour, 136,600 BTUs. Airflow, when you know the furnace output, these are your rule of thumb sizing, typically a 14 factor. Cooling, 400 per ton, you can switch it to 350. Total sensible heat calculation for your thermal efficiency. CFMs, your delta T, get your BTUs, put your input of your furnace in here. This tells you your thermal efficiency. Calculating CFM from pressure using traverse method. You put your length and your width in here, go over here. Now this is when you do it manually. You're going to enter all your pitot measurements to get your static pressure. Also, when you're traversing for multiple readings, put your length and your width, and this will tell you your drill points on your length, or your insertion depth. You can either go drill point, insertion, drill point. And I did them in millimeters because millimeters is far more easier than trying to divide up a bunch of fractions. So basically what you're going to do is you're going to measure across here 1973, 127. You're going to measure all those millimeter, make your drill marks. Then you're going to come in with your probe and you're going to go in each hole. You're going to go 34 and you're going to go these 5 measurements. You can also use this with a manometer, digital one, just to tell you where your drill points and your insertion depths are, and that'll actually give you your CFM. Same thing with round ducts. If you're doing a round duct, same thing. You have a 12-inch diameter duct. You drill a hole at 0, right? You come around to 160 millimeters, you drill your second hole. 319 millimeters, drill your third hole, and here's all your insertion depths. Here's adjusting CFM for temperature and altitude. All 3 of these are mostly used if you're doing everything manually. With the modern probes, this can all be done done a lot quicker and easier and more effective. But to adjust the CFM for temperature and altitude, obviously your CFM, your temperature, your altitude, and there's your correction factor, and here's your CFM. Let's pop up here on the right side. Psychrometrics, your properties of air. If you're not using static probes, wireless probes, and or if you're just getting your return air, your dry bulb, and your humidity, and your supply air, you can get all your properties of air. Put your design CFM in, your actual CFM, and this will tell you more about your properties of air, your delivered tons. These numbers might be made up, so they might be way off, but the calculations are correct. Sensible heat ratio, measured CFM, estimate. A couple more calculators here. Coil enthalpy. If your wet bulb at sea level. If you know your return and your supply wet bulbs, here's your difference, your CFM, your tons of cooling capacity. Calculating filter face velocity. Your length and width, your measured CFM, here's your feet per minute. Calculating CFM for electric heat, you need your volts, your amps, your delta T. This tells you your watts, your BTUs, your tons, your CFM. Here's more for duct traversing. Round duct or rectangular duct. This is just to get all your insertion points so you don't have to pull out your little chart and try to remember everything. And again, I put them, in this one I put them in inches and in millimeters. But again, it's so much easier to use millimeters for these. Calculating duct loss. I'm not fully happy with this, but it does work pretty good. And here's a picture on here to show you where to put your probes. And that is basically it for Airflow and Psychrometrics. And thank you for watching.